So yeah, good afternoon. My name is Annika Janssen and I'm working at the Research Institute Senckenberg, and on behalf of the BGR we are investigating on the myofaunal organisms in the German license area of the CCZ. So therefore today I'm presenting as a representative of the BGR. So the German license area is divided in two parts, the eastern and the western area. And to date, the sampling activities focused on the eastern license area exclusively. So here you can see a bathymetric map of the eastern German license area, measured by the Simrad EM120 multibeam. And the area comprised roughly 6,000 square kilometers at a water depth of 4,000 to 4,400 meters. And about 80% of this area are low relief areas, except for a few seamounts, as you can see here in this map. So we used the multicore for obtaining myofaunal samples, optionally a 12 or 8 tube multiple core. And after retrieval, the nodules and the first 5 centimeters of sediment of the core were fixed separately. Then in the laboratory, all nodules have been photographed at all 3 axes, and the displacement volume have been measured. And then the nodules were passed through gently. And the extraction of the organisms from the sample has been done by separate centrifugation of the cracked nodules and the sediment. So our biological sampling started in 2010 with the German research vessel Sonne. During this cruise we obtained 50 successful multicore holes at 5 working areas, distributed over the entire license area. And later on in 2012 we had a joint cruise visiting the French and the German license area with the French research vessel La Talente. And for the German license area we just have 1 successful MUC hole. Due to bad weather conditions the multicore failed several times. So this is the reason why we sampled additional multi-tube substitutes that are box core sub-sampled with the core, but these samples have been used only for the qualitative analysis. So in 2013 we sampled with the research vessel Kilo Moana. We had 12 successful multicore holes in 2 predefined reference areas. We sampled 6 multicores in the impact reference area, that means the potential mining area, and 6 multicores in the preservation reference area where no mining should take place. In 2014 we again sampled with a research vessel Kilo Moana. We had 20 successful multicore holes, and we resampled 12 multicores from 2013 for a for 1 year period timescale comparison. And additionally we sampled 8 MUCs at a potential mining area too. In spring of this year we had 2 cruises with the German research vessel. We sampled 29 successful multicore holes, and again we resampled the multicores from 2013 and 2014 to have the 2-year period timescale comparison. And we additionally sampled 17 multicores in the northern and eastern parts of the area. So in total we have 77 multicores with at least 5 cores for quantitative statistical analysis, which have been fixed in formal. And we have 77 multicores with at least 1 core for qualitative genetic analysis, which have been fixed in depth. So now coming to the results. Typical for myobentic communities, the nematodes are the most abundant taxa, ranging from 83 to 86%, followed by the copepods and the annelids, and all other taxa like the ostracodes, the tardigrades, the loriciferans, the gasotrees, the chinorhynchs, rotifers, the myobentic isopods and taniids, and additionally the Tantulocarida comprise together less than 2%. And the total myobenthos ranged in the German license area from 112 to 722 individuals per 10 square centimeters. As I told you that the nematodes are the most abundant taxon, they range from 90 to 672 individuals. Followed by the copepods, which made up to 67 individuals per 10 square centimeters. All other taxa were far less abundant. So then we analyzed the metazo-myofauna communities at a local scale, that means within the German license area, and we compared the myofaunal assemblages between different working areas, as you can see here in this map. And we found out the mean densities of the working areas ranging from 170 individuals to 366 individuals per 10 square centimeters. And we found out that the densities between the working areas did not differ significantly. And in addition, we could not find differences in the composition of myobenthic communities in different working areas, but this is based on the higher taxonomic level. So then we compared the impact and the preservation reference area, as I told you before, the impact area where mining could take place in future and preservation where no mining should take place. These both areas are 60 kilometers apart. So here we found significantly higher densities in the preservation reference area, ranging from 154 to 602 individuals per 10 square centimeters than in the impact reference area, which ranged from 96 to 452 individuals per 10 square centimeters. But we did not find significant differences between these both areas in terms of the composition of myobenthic communities. So then we compared the myofaunal assemblages between the nodule-fascias. Therefore, we grouped the nodules of a core into different size classes, from small to large. And the medium densities ranged from 238 individuals at fascies A to 341 individuals at fascies C. And again, the densities between the nodule fascias did not differ significantly, and we did not find significant differences in terms of the composition of the myobenthic communities in terms of the different nodule fascias. So then we compared the myofaunal assemblages between areas with nodule presence and absence. So again, we found higher significant densities in the nodule-free areas than in the nodule areas. That means in the nodule areas we have mean abundance of 369 compared to the nodule area with 282 individuals per 10 square centimeters. But we did not find significant differences in the community composition in terms of nodule presence. So then we analyzed the metazo-myofaunal communities at a regional scale. That means we compared the German and the French license area. And we found significantly higher densities in the German than in the French license area. The average density of the German license area is about 311 individuals per 10 square centimeters compared to the French license area with 200 individuals per 10 square centimeters. But interestingly, we found significantly higher densities in nodule-free areas than in nodule areas for both the German and also for the French license area. And in addition, we found small but significant differences between the German and the French license area in terms of composition of myobenthic community. So then we used the Spearman-Ranks correlation to test for a relationship between the myofaunal densities and the displacement volume of the nodules per core. And we found out that the presence of the nodules affects positively on the myobenthic diversity, that means at least in terms of the major taxa, and affects negatively on the total myobenthos, that means at least in terms of the nematodes, but does not affect the remaining taxa. So a colleague of mine, Dr. Ravai Singh, analyzed in his thesis the nematode community from different substratum, the nodule crevice, the nodule sediment, which was directly attached to the nodules, and the bare sediment. And he found out that the nematode community of the nodule crevice differed significantly from the community of the sediment. So he found 111 genera and 27 families in the bare sediment. He found 70 genera and 23 families in the nodule sediment. And he found about 43 genera and 19 families in the nodule crevice. So as you can see here in this picture, the comparison of the relative abundance of the most abundant genera showed that the Nordio crevus community seems to be a subset of the bear sediment community. For instance, in terms of the genus Thalassum, Monstera, Leptolimus, and Desmus gulax. And in addition, he found out that the Nordio crevus substratum does favor some nematode species. For instance, in terms of the genus Camacolimus. So then we analyzed the copperpot community. We tested some nuclear and mitochondrial markers. And the 12S, the 28S, and a short fragment of the 18S, SSU. And the success rate of the amplification were only low to moderate, the lowest for the 12S and the highest success rate for the SSU. But what we can see here is that based on all genetic markers, the analysis revealed a very high copperpot diversity, showing a high abundance of the singletons. The singletons means that the species have been found just once. So then we found some representatives for a wide distribution of some copperpot species. Analyzing 302 sequences from the German and the French license area, they could be assigned to 255 motus, and 85% of them were singletons. And we found just 1% of the motus shared between the German and the French license area. Then we compared our dataset from the ZCZ with the dataset from the Kuril-Kamchatka Trench, which is located in the Northwestern Pacific. And interestingly, we found 2 motus shared despite the large distance of approximately 10,000 kilometers. So in future, there's a need to determine the meiofaunal community to the lowest possible taxa, of course. And then we need to go on with the genetic analysis in terms of the species distribution and connectivity. And in the next year, we will have a cruise to the German license area, again with the research vessel Kiimwana, and we will sample additional multicore deployments to analyze morphological and genetic analysis. So yeah, thank you.
Some question?
Yes.
I just want to add that the German Ministry of Economics is planning to carry out a pre-pilot mining test. Currently, the decision has not been taken, but expected by the end of the next year. And so one valuable outcome of this series of workshops in the perspective of a contractor would be, because we have to submit environmental impact assessment 1 year before the test. So a valuable outcome would be a kind of guideline for us. What exactly do we have to investigate? Which studies do we have to conduct in terms of biodiversity and follow through in order to provide a high quality environmental impact assessment? That would be something for us.
So this tentacle carry that you show, was that found in the sediment or sitting on the hopper to collect the copperpot? You found the larva in the sediment or you found the adult on the copperpot?
I found the larva in the sediment.
Oh, really?
Mm-hmm.
Great. Small, extremely small. About the seed we talk about, they're down to at least only 50 microns. Very small.
And then, yeah.
You showed the fauna in the nodules, showing that the nematodes genera, at least ones you have been showing, were the same as in the sediment, but in different proportions.
Yes.
Is that correct? Did
Yes.
you find genera that were not found in the sediments? And the same question actually for what about the copperpots?
The copperpots we did not analyze yet within the
But they were
crevice.
present in
This is only based on the nematodes. So this is not my work, so I cannot say much to that. But maybe Pedro can tell something because his PhD student did this.
I think there is no genus exclusively in the nodules. But the problem with this analysis in this study is that the abundance in the nodule is very, very low. So we could not really reproduce the studies in the distal area where you have very big nodules and completely different nodules. The nodules in the CCC they are more compacted and smaller. So really the amount of myofauna living in the nodule is very low. So you have a very biased abundance of nematodes if you compare the sediment with the nodule. So you have thousands of nematodes in the sediment and you have about 20, 30
So
in the nodule.
this Camacolimus is maybe 3 individuals. I mean,
Yes, but I don't know exactly how many, but the proportion of this Camacolimus species is greater in the nodule
Yeah.
than outside.
yeah, but it would be good to have an idea of what the densities represent to make the comparison.
Thank you both for your excellent presentation. I have a question regarding samples with type C. If the nodules size is about 9 centimeters, how did you use multicolor to obtain to sample this?
So
Because the tube is around 10 centimeters.
it's not just in this way, but it can be in this way. So here you have the tube, and the 8 centimeters are in this way. So it should fit.
These tubes have a diameter of 12 centimeters.
Yeah.
So it's a
12
really big
also
nodule.
is another type
So
of.
10.
Well, it's
10
10 centimeters,
centimeters.
still large.
The standard.
Sorry, just concerning this molecular data, can you slide it, please? You use okay, this is all copy paste. Do you have an explanation what some of these genes do works?
No, we don't know. Maybe you can tell us.
Yeah, I don't know.
We don't know really, but
Well,
we
it's
always.
surprising to use 12 fast. Very fast. But it is not much.
But this is good to separate species also.
Yeah, but it doesn't recover very much. So that means this is mitochondrial genes probably too viable to get any universal primers with replicants. That could be an explanation.
It's a, yeah.
I don't know, I have no experience with mitochondria.
We have
It's usually used in that.
the success rate with shallow water copper pods is relatively high, and we don't know why deep sea copper pods all these things come from.
We have actually BGR have the same problem in the Korea workshop in macrofauna. They have a very poor recovery, and using I don't remember what they were using. And one of the experts in that group mentioned that one of the effect of sieving with the warmer water than the water that you collect on the bottom, it produces this effect in the recovery of DNA.
When we don't see,
Yes, that cannot be the case for this.
It's not the case.
Because we do not see this, so we need to centrifugate. We cannot.
But just to mention that the little detail on the sampling, it can have an effect.
But they have been frozen and you sort them after frozen? Or how do you do it?
No, we fix them in death, and then we centrifuge these samples, and then we sort out, and then we did the genetics.
So how's the DNA extraction quality?
Sorry?
Do you get the high quality of the DNA to begin with?
Yeah, sorry.
High quality of the DNA some
Yes, sometimes yes.
So you just cannot amplify.
So just going back to Jan and the presentations we gave this morning, that's a lot of sequencing. These are chain termination sequences, Sanger sequences. They're single sequences. Yeah. So there's about 10,000 pounds worth of sequencing there. Given that you could, my question is, given we could do probably more, do you think in the future you might do some more,
Yes,
like
of
high
course.
throughput approaches? Because then you don't necessarily have to restrict yourself to copepods and other groups.
Yes, so we can try to do this. But a problem we had with the fragment of the SSU was that we had a very low resolution. So they did not resolve on species level. So we had clusters which are completely different species. So that was a problem of the SSU.
But then you've got 28S, you've got 12S, you've got 16S, you've got CA1.
Yes, of course.
There's a whole wealth, there's a whole toolkit, especially for things, like overpods, which I assume well,
So,
they're probably amplifying with different.
yeah, just one question. It does mean that they come to the same specimen? It's mean the one that worked with 12S, they want to SSU, or is this a different specimen?
Different specimens. We started with 12S and 28S, and then we skipped the 12S and the 28S because for the new samples they did not work again. We could not amplify the 12S and the 28S. So then we start using the SSU. But then we had the problem that they do not
Yeah,
resolve
but
on
I mean
species
that
level.
if you use first the SSU, then you know which one works, and then you
Yes,
go back
yeah.
to 12S and
Yeah.
you see whether there's a
Yeah.
primers or not. That's just my.
And
And what was a particular group, particular family more successful, or is it?
Cannot say.
Yeah.
Cannot say.
It's similar as with nematodes.
Yeah, but honestly, forms also doesn't work. It's not true that you should not think that 200% of the specimen will work. It's not true, and we never understood. We even see the cell, and it doesn't work. For some, this is.
It's serious.
So there is always like 50 or 30%. We don't have that. That's it.
Yeah, so
With the primers, it would very well perform. Designed perform. Still, you cannot get that for some specimen for some reason.
thank you very much